Well, good evening, everyone. We'll start the AAPS webinar in about 2 to 3 minutes, give everyone an opportunity to log in. We have a lot of registrants, a lot of excitement for this talk this evening. So hold tight. Okay. Good evening, everyone. My name is Jesse Goldstein, and I am one of the committee members of the Association Technology Committee. Thanks for joining us this evening for our Technology Committee webinar on AI and plastic surgery. We have adopted a subtitle for this webinar, Improving Decisions, Training, and Efficiency in Leadership. This is the first webinar of the year for the association, and I think it's a really great kickoff to our meeting season, which is starting this weekend in Kauai. I hope to see you all in Hawaii. We're very excited. For those who tried to join us last week, thanks for coming back. As the technology committee, I think it's important for us to demonstrate that even we occasionally need a reboot. And occasionally the technology committee can't even tech. So I appreciate everyone coming back and the enthusiasm for our speakers and the topic at hand. I'd like to briefly introduce our panelists, and then I'm going to turn it over to them. Kicking off the evening is Graham Schwartz from the Cleveland Clinic. He's the Vice Chairman and Director of Microsurgery and Breast Reconstruction Fellowship. He is an internationally recognized leader in microsurgery and lymphedema care, and we are really privileged to have him speak to us this evening. He'll talk about the evolution of plastic surgery specific GPTs and RAG models and how he has applied them in clinical practice and provides a user's guide for us. Next, Amanda Gosman, who's a professor and chief of plastic surgery at UC San Diego and the director of craniofacial and pediatric plastic surgery at Rady's Children's Hospital. Dr. Gosman will speak on education and the use of computer vision in the operating room, including navigation and visualization. And finally, Dr. Peter Rubin, Distinguished Chair of Plastic Surgery at the University of Pittsburgh and Professor of Plastic Surgery and Bioengineering. He's, of course, the past president of ASPS, and he's going to share his insights on leadership in plastic surgery. With that, this is a webinar format. Please respond and use the chats for comments if you are able to. I'll be looking through those with and ask the questions directly of our panelists. And with that, I'm going to turn things over to Dr. Schwartz.
Thanks, Jesse. And hello, everyone. Good evening. It's really terrific to be part of such a distinguished panel and an exciting topic. And, thanks again, Jesse, for really putting this together, and for the tech committee to sort of acknowledge the importance of this topic. I'm going to share my screen here. Let me know if you can see it.
Looks great.
Looks good. Okay, perfect. All right. So, over the next few minutes, what I want to do is I want to walk you over, or walk you through rather, why plastic surgery needs its own decision support tools. It's really been exciting to see sort of what our cross-disciplinary AI research group has been able to kind of put together. I want to talk a little bit about why we think that these systems work better than general purpose AI for what we do. I want to talk a little bit about where I think this particular field is heading next. And I want to start with sort of an example to kind of put things in perspective. So there's a person who walks into my clinic, 74-year-old woman with Merkel cell. I know some things about Merkel cell, but I do mostly breast recon. I do some lymphedema, sarcoma, right? Typical microsurgery stuff, but I'm not seeing Merkel cell carcinoma every day. I know it's dangerous. I know that some of the guidance around kind of margin width has changed in the last couple of years. I know lymphatic mapping in the head and neck can be a bit tricky. I know sentinel node may have a role in this particular entity. Patients need radiation, they may need immunotherapy. These types of things are sort of, especially the immunotherapies, they're changing all the time. And that's nothing to say about the surgical and ultimately the reconstructive plan, which kind of hinges on all these other things, right? And so, I have maybe 20 or 30 minutes with this patient in my office. And so in order to really get all of the latest and greatest information, I would need to spend maybe like 20 minutes, doing, various searches of guidelines and so forth to really understand and put together a coherent plan for this patient. But wouldn't it be great if I could avoid that and have that knowledge at my fingertips? And I'm pretty lucky. I'm in a well-resourced environment, but what about the plastic surgeon who's kind of in a rural area or in a regional area that doesn't really have this kind of information, at their fingertips. So, I think this kind of builds a case for a specialty specific type of a clinical decision support tool where I think you can really affect patient outcomes pretty powerfully if you had the right information at the right time. So, that begs the question, why not just pop it into ChatGPT, right? I think that, increasingly we may be able to, to do that. These systems are getting better and better. But traditionally, the data has been a bit concerning. Over 30% of the time when we were using, at least back in the days of ChatGPT 4 or GPT-4, 30% of the time we were getting hallucinated answers, hallucinated references, fabricated citations up to 20% of the time. You may get an actual citation, but it may have nothing to do with the query that you entered into the system. And even today, when you put in complex clinical scenarios, only 50% of the time you're getting correct diagnostic accuracy and treatment planning. And really the problem is architectural here. It's kind of that there's no specialty grounding. There's really no verifiable citation trail, and there's no real good awareness of the workflow of a plastic and reconstructive surgeon. So, back when ChatGPT came out, we got really interested in this, and we wanted to try to think about how could we tackle this problem ourselves. We've been working a bit with machine learning applications, and really just became fascinated with this generative AI and LLMs in particular, just like everyone else. And so we began our own journey with these knowledge systems. Our first system that we built was Plastic Surgery GPT. It was based on a GPT-2, which is an open source model. We trained it on 25,000 plastic surgery abstracts, and it worked pretty well. The model understood plastic surgery language better than a general version of GPT. But the problem was there were still some limitations. The answers were often correct, but wrong answers were delivered in a pretty convincing fashion. There were some hallucinations, and sort of on a larger level, every time evidence would potentially come out, you'd have to train the system again. You'd have to fine tune the entire system again, which actually is fairly time intensive and computationally expensive. So, in order to do that, you kind of readjust all the model weights, and it's just not very practical to do that kind of thing. Every time you would put a query in, the apologies. Every time you put a query in, you may get a slightly different answer. So that's sort of when we began to look at a system called RAG, or Retrieval Augmented Generation. And basically, what we do here is instead of baking the knowledge into the model itself, we keep this curated library of peer-reviewed papers. And so when you ask a question, the system pulls the most relevant papers from the library first and then uses them to generate an answer. The actual citations get attached to that, and you're able to keep the library current without retraining the entire model. So the answer is tied to real sources, and it's verifiable and traceable. So, this is kind of the direction that we decided to move in. All the way on the right side of the screen is kind of a flow diagram of how that system works. You basically create this, again, library of knowledge. You are able to then sort of create a hierarchy of information based on that library of knowledge. And then you use your LLM to query that knowledge base to get a citable, traceable answer. So this this slide depicts our journey, if you will. Over the past 2 years, our groups built and published a suite of these systems. Again, first starting with Plastic Surgery GPT, and then we built Hand Rag, which is a rag system for hand and upper extremity, Micro Rag, Aura, which is our aesthetic system. And then we kind of moved on to build Casper and Burn Rag, Casper being the craniofacial system, Burn Rag being obviously burn. And really directionally, what's important here is starting from this open source model to using these retrieval augmented generative systems to becoming more multimodal. So in Casper and Burn Rag, we're actually able to upload some images and use those alongside text queries and generate answers that are grounded in our subspecialty specific domain knowledge. So these metrics come directly from the published validation studies that we've done. Quick note on the columns, the evaluation framework sort of evolved across the suite. The earlier system used metrics called faithfulness and relevancy. The later ones used semantic similarity and G-score, and they're measuring kind of related but not totally identical things. I would just treat each row on its own terms. But what really holds across all of them is that there's consistent performance above 0.85 on the primary sort of computational metric that we're looking at. And that's kind of weighed against the statistic that I gave before, which is that 30% of GPT-4 answers were hallucinations, right, in equivalent medical tests. And that gap is an argument that we need to have these domain-specific architectures. There are clinical members of our team that reviewed outputs of all the systems. It's not as a substitute for formal guideline-based benchmarking, but these studies weren't really designed to do that. But our clinical team, which consisted of fellows, residents, even my partners, basically were able to, sort of confirm that and check that these were coherent answers that these systems delivered in line with the accepted practice. And the point is not that we've kind of solved the problem completely, but it's definitely demonstrates that this kind of approach using these types of systems is kind of the way to go. So I think one of the most important transitions in the field is a move from text only to multimodal, or systems that can look at images. Surgeons, certainly plastic surgeons, we don't think in text alone. We look at photographs, imaging, anatomy. We synthesize all of that with the literature. This is an example from our Casper paper in the Journal of Craniofacial Surgery. User can upload a clinical photo, and the system can kind of, identify anatomic features here, certainly syndromic, a bunch of syndromic features, and it can pair these with observations from our curated, body of literature. And it can return a prioritized differential. In this case, Crouzon syndrome is most likely, with some other possible diagnoses as well. We've demonstrated this similarly in our burn rag type of model. Burn is important in terms of the fact that you need to understand the depth, the wound appearance, the anatomic distribution, and kind of look at these features alongside the clinical context. And so you can use this in addition to kind of the latest and most impactful literature to ultimately design a management plan for a patient with a burn. So the goal here is getting surgeons to trust these systems, right? And we know that you can't have a blind trust, right? It has to be justified, right? A surgeon should be able to see where the answer came from, check supporting citations, understand when the evidence is limited or when the system is reaching. And that's fundamentally different than asking a general chatbot, for the answer and just hoping it's right. The library, it's curated, it's peer reviewed, and you can see which papers the answer was drawn from. And every claim you can trace it if you want to back to the specific source. And because the output is structured and cited, you can verify it in real time against your own clinical judgment. So, I would say that, what sort of comes next beyond RAG, is there something really, really fantastic? I would say that actually this concept of a RAG model is being integrated more and more into all the tools that we see now, and into things like ChatGPT and Claude and all this kind of stuff. It's sort of a fundamental piece of infrastructure. But what is growing, I think, what are next steps are, introducing more multimodal type of input. Having these, so-called agentic workflows where they can be more adaptive. They can plan a search. They can iteratively retrieve things, structure the answer, and present it to you after having checked it against available evidence. Concepts in terms of structured knowledge bases also are evolving. Things called knowledge graphs, where more nuanced relationships between concepts can be gleaned, and the system can actually understand that and deliver information based on that. And then lastly, systems are moving more so that we can hopefully trust them better, and we can have a sense of their bias, and make sure that there's appropriate governance before we provide them with complete autonomy. So what's beyond our current architecture? Again, we're already sort of doing a decent amount of things, and maybe that fall into the agentic category. We're taking clinical questions, we're breaking them into sub-questions, we're doing searches, we're synthesizing the answer, and that's already somewhat sophisticated. What's next isn't really generally a huge leap or categorically different. Again, it's kind of making things more adaptive. Right now, the systems plan searches up front, but again, like being able to kind of adjust in real time, maybe pulling for understanding that, like, okay, here's some information. Now we have to go and look at treatment guidelines or staging calculators, or maybe look at the patient's own EHR data. And instead of generating, again, one answer, it can check that answer before presenting it to to the person. And so really, honestly, the benchmark data on these more elaborate systems that we're seeing are really showing only more moderate improvements over the traditional RAG systems. That may change in the future. There's always a little bit of a lag between research and what's going on. But still, I think this infrastructure is really kind of important to know about. So what does it take to have these types of systems reach the patient bedside? It kind of gets a little more complicated, but it's where the rubber meets the road, right? First, you want to have some prospective clinical validation. Published validation metrics are starting point, but we really need real patients, real outcomes, and we need to compare them to expert consensus. Can be difficult to do this at scale, but we need to continue to try to do it, especially as a specialty. Secondly, we need FDA alignment. It's interesting, there's now over about 1,200 AI-enabled devices authorized by the FDA. Our tools that I describe here fall under the software as a medical device framework. And depending on how we describe what they do, they can require a 510(k) submission, a de novo pathway, or if they really merely synthesize existing guidelines and the clinician can independently review the basis for the recommendation, they might qualify as a non-device clinical decision support tool. And this really matters enormously for how these systems get developed and deployed in the real world. Third, there's EHR integration. And if it's not, if you're not using these systems at the point of care, when the question comes up, will these systems get used and will they get used appropriately? It may be best to have them in the EHR, it may be best to have a standalone app. I think it depends, on the person's, and the practitioner's workflow. Transparency and bias is really an important thing to keep in mind with these AI tools. The guidance from the FDA back last year requires documented performance across different patient demographics and very clear labeling so users understand exactly what the AI is doing. So if the clinician can't independently review the basis for the recommendation, and in these RAG models you can, but if you can't, right, and it's a little bit more opaque, then for sure this software as a medical device will be regulated by the FDA pretty highly. And lastly, it's really probably the most important thing and matters to everyone who's on this webinar probably, that clinician education is super important, right? Because at the end of the day, in the current legal landscape, the final decision-making responsibility is on the clinician, not the software vendor. So it means that really education about how to use these tools appropriately it's not optional. We really need to know how to do that safely for patients and also to protect ourselves. And so to close, a few things. I think general AI is amazing, right? ChatGPT, Claude, Grok, all these things, super, super amazing. But in its current state, it's not accountable enough for plastic surgery decision support. We need domain-specific, citation-grounded systems, like the ones that I described here. And the reason is because surgeons can actually verify the sources and the material against their own clinical judgment. I think the field is moving toward a multimodal type of a situation. We'll see more agent assistance. We'll see more clinically integrated workflows. The bottleneck really isn't how good the specific models are anymore. It's more the validation. It's more the safety, the fit into our daily workflow, and accountability. And so these aren't all things that OpenAI or Anthropic is really gonna care about in a dramatic way right now. And these are problems that need to get solved by specialty-led research, by building the tools and setting the benchmarks ourselves by our group and the folks who are in this forum. We really need to be defining what responsible clinical deployment in plastic surgery actually looks like. So with that, thank you so much for taking the time to join tonight. I want to specifically thank my fantastic interdisciplinary group and specifically call out Burke Osman, who's our postdoc, who has done a ton of this work. Some of our residents, our medical students. I also just want to do a gratuitous plug for our robotics and plastic surgery conference in August 13th through 15th. Hopefully you all come. And I look forward to the presentations and more discussion. Thanks.
Thanks, Graham. That was really informative. There are a couple of very specific questions tailored to your presentation that maybe we'll let you go through while Dr. Gosman gets her slides set up. The first, I think, is related to open evidence and how the tools that you've developed are differentiated from open evidence and or maybe even overlap with them. Um, is there a need to continually reinvent the wheel, so to speak, or does open evidence achieve the similar goals to what you have done with these very domain-specific tools? What are the advantages of using these domain-specific tools over something like open evidence?
Yeah, and I really thank you for the question. I mean, I think it's important, right? Should we be relying on one specific company and one specific entity to, give us all of our, information and sort of curate it? I mean, I think that's, you know, I don't necessarily think we should be doing that. But I think more importantly, open evidence has always traditionally been a bit more oriented toward kind of general medical knowledge, right? More oriented toward, internal medicine and, sort of, again, more of a generalist kind of approach. And so could that be good for, 80% of what we need as plastic surgeons? Certainly that's probably the case, probably will be. And you can make that argument too, as OpenAI and Claude, for healthcare, OpenAI for clinicians, they're doing these same types of things. But when you get down to kind of some of the more specific things, right, the more highly technical, things that we do in plastic surgery, being able to have sort of a very highly curated, knowledge base is, I think is very, very useful. And so it may not be a question of like, or it's probably a question of and when do you use, each system.
That's awesome. Thank you. One other question about how you've trained your models and ingestion. Is there a difference between utilizing abstracts as the main tool versus if you happen to train your models on the entire manuscripts, for example?
Thousand percent, yes. And so that initial foray, that plastic surgery GPT-2 was trained on abstracts, and the subsequent models were trained on full papers, and the creating knowledge base on full open source papers. So yeah, you can grow the knowledge base by including more more open source papers, or getting behind a paywall and getting that content is a different story.
Okay, wonderful. All right, we're going to turn it over to Dr. Gosman now, and stay tuned. If there are any other questions for Dr. Schwartz, he will be around, and we can tailor those questions to him at the end of the Q&A.
All right. Thank you. Jesse, can you guys see my screen okay?
Yeah.
Excellent. Well, thank you guys very much for the opportunity to join this webinar on a topic that we all find incredibly fascinating. So I'm going to talk a little bit about the use of AI in plastic surgery education. And obviously what Graham just spoke about is a major contributing component of that. No financial disclosures here. When we think about just kind of how we've been educating people for a very long period of time, I think of it kind of as a very mechanical, sometimes tooth intermittent process. And we have been in the process of, just kind of reviewing what tools and our approach to education. And I think we're kind of at a crossroads as we're hoping to really reassess traditional methods and look toward, competency-based education. I think that this is a perfect time as our technology continues to improve through AI and a variety of other kind of methods. But obviously, as Graham had mentioned, the ability to acquire knowledge and adaptive learning, which we already use in a lot of our examinations, are incredible opportunities for that. And there's some interesting work that's been done in other specialties and some within plastic surgery itself about how to utilize some of that adaptive reasoning to virtual patients and simulation. There's been really interesting projects that have been done creating those virtual patients for rare diseases such as craniofacial syndromes and being able to generate images and be able to navigate the learner through different virtual case discussions so that you can make them increasingly more complex based on the way that the learner is answering these things. One of the areas that I've been very interested in is just the use of intraoperative computer vision and feedback and how we can really try to strive toward acquiring and developing more objective tools for assessment, which I think are very much aligned with the goal for competency-based training. And in addition to what we do in the operating room, just like natural language processing, both in terms of the feedbacks that may be given in a clinical environment, whether it's an operative environment or as we utilize AI scribes and, our electronic medical records, how can we leverage those very similar technologies to be able to provide feedback to our learners or for the creation of standards that we are then looking for them to match without necessarily having to incorporate massive amounts of data, but using it a little bit more strategically. And as have been mentioned before, and I think are always a concern for anything that we're doing in this space, is really thinking about the ethical and the inherent bias that is acquired or that is, just kind of sometimes hiding in many of these technological applications. And I'll talk a little bit about that as well. And then, future applications are really, I think, just infinite, both in our own clinical care and certainly for the education of our learners. So, this is just some of the kind of things that we have usually been, somewhat limited by in our traditional educational approach. And most of that just like utilizing a set curriculum and not having that adaptability, both toward an individual learner, but also toward a learning environment, and trying to think of how we can create more continuous objective assessment methods as opposed to just that intermittent subjective faculty evaluation. I think our opportunities both in the clinic and in the OR. And as I mentioned, I think there's a lot of been interesting work done in other specialties about how to utilize some of the imagery that we have in the operating room as well as in case-based learning for both assessment as well as just acquiring knowledge. And certainly, I think that there has been a lot of very interesting satisfaction data that's also we can certainly talk about in the discussion about how learning is so much different now with the accessibility of a lot of these tools. Has been a lot of that has been published in a UGME space, just looking at knowledge acquisition. And I was joking with my daughter the other day, just, when we used to have to try to find out information and looking up journals and then having to go make photocopies and read those journal articles. And now it's just like a simple text prompt for, that's well crafted and peer reviewed by some of the tools that have been developed. And this not only makes it easier, but also opens up a whole world of knowledge at the fingertips of the next generation, and how can we make sure that that's going to be optimized and really as evidence-based as possible, as well as how can we just try to identify or potentially, anticipate some of those things that will create areas of bias. And these are just some of the, kind of summaries of some of the studies that have come out looking at this space, both in dynamic question banks, which have been used for a long time, as well as in these tutoring platforms. And looking at the study that was done from Pittsburgh as well, and having ChatGPT take the in-service exam, which was very interesting and informative as well. I think that case-based learning is something that's really very compelling, and I think something that plastic surgery can definitely delve into. And certainly, as many of us are involved in our board and development of questions, not just for in training, but for certification, that this has a lot of promise in the future, and has the opportunity to overcome a lot of the limitations that have previously existed in that space. And this computer vision part, I'll go a little bit into the detail of that, but this is something that I think, most of our ORs are now have cameras that are embedded, which were things that were, difficult to acquire 5 or 10 years ago. That there are a lot of interesting, metrics that can be utilized to assess technical skills, including efficiency of motion and time to completion. And in addition to that, like what can we utilize to acquire a result on table or with a learner that is being mentored or supervised in various settings that will either demonstrate that they have been able to achieve competency in a skill, or components of competency if that is not possible to do completely autonomously. So I think that there's a lot of performance trends that can certainly be driven, and certainly identifying those learners that are at risk early versus those that may be excelling, or both have implications for certainly for competency-based training as we look to be innovative in how we're utilizing that critical period of time. I think we also have an opportunity to really critically assess our own learning environments, and if we are able to develop tools that allow for longitudinal continuous assessment, we can identify our gaps that may exist in our own programs. Just another comment on bias and transparency. I think, the algorithms, as have been mentioned, are certainly, based on the data that are used to build them. And, having transparency and validation are things that are really critical for, things that may be utilized to make decisions about someone's advancement or their career trajectory. So having that oversight and kind of anticipating these. And I like to use this example. I'll give Steve Williams a credit for introducing me to this, but this was a study that was done by a collaboration from Oxford and Johns Hopkins, by utilizing this prompt in a large language model for image generation was something that was really telling in terms of the data that exists as you look at what is put into any system, or where that data is being pulled from, can create a lot of difficulty. So this was a Black physician taking care of a white patient, and multiple iterations of this image still failed to produce anything that was really aligned with that prompt. And I know many of us probably have had similar frustrations utilizing things like that, but I think it's always really important to keep in our mind what those biases may exist, and just the information that is widely accessible to any of these models that are pulling from existing information. And the data that goes into those does need to be scrutinized historically as well as contemporaneously. So these are some of the tools that have been described for learning and for clinical care in that clinical context of our learners, and identification of perforators for mapping interoperatively. I'm going to talk a little bit about our photogrammetry projects. There's also been some interesting work done on flat monitoring and certainly some of the mobile tools to try to utilize AI and remote learning and projection in a space where there may be learners that are distant from their trainees. So computer vision and intraoperative assessment in this educational space, I think, has a lot of valuable applications. And one of the things that we've been really trying to refine at UCSD were the use of a model of photogrammetry or structure from motion, where you're basically creating three-dimensional images from a two-dimensional image. And the program that we're currently utilizing allows us to generate this image using just a smartphone. It's usually an iPhone, and creating a dynamic swipe. Think of it as kind of like a layer cake where you're doing multiple passes over an image to create this three-dimensional image. And so essentially from that motion, we can create a three-dimensional structure. And that gives us also the ability to feature extract and correspond those images to a variety of other high-resolution inputs in this software system. And for the example that we've been focusing on, it's been for cranial vault reconstruction and trying to utilize that intraoperative imaging and then the image correspondence for assessment of volume change as well as symmetry. So the high resolution inputs that we're utilizing are the preoperative CT scan and then taking images intraoperatively at different points during the procedure, both of once the bone is exposed and then after the reconstruction is created, matching those features and having a final registration. So here's kind of an example of the photogrammetry model that is generated from doing these layer cake types of swipes from the images in the on the 2D images on the iPhone. This is an additional stage of the procedure where the frontal bone flap and frontal orbital bar have been removed. And this is once the frontal orbital construct and anterior cranial vault have been remodeled to try to kind of align all of these features. And then they can be kind of feature mapped and overlaid upon each other so that we can line up those critical landmarks and try to get some assessment of what is occurring here. So here you can see the calculation, both of the change in intracranial volume as well as the change from the preoperative CT scan, the preoperative image, and then the on the table construction of the frontal orbital advancement. And that is something that we've been utilizing to try to see if we can make an assessment. And I think the goal is that this could be used for any kind of three-dimensional assessment of form or structure that we're creating. I think that it could easily be adapted to something such as like a breast surgery where you have a preoperative, image and then something that you create as a standardized result by creating these point clouds that are, utilizing multiple data points from a single image. And so it's a relatively quick process. The acquisition time for the images is less than a minute. And then it does take a little bit of time for the processing and then being able to overlay these images and the mesh that is created from them to be able to assess what the change is in their volume. So it can be quite quick. And I think, the options that this provides to us is really that assessment of being able to see how much volume change that we have, whether or not we have symmetry. And then the goal ultimately is to integrate this into, really augmented reality platforms that we can also potentially integrate into large language model. So talk about that a little bit. These are kind of the two branches that we have been going into from this photogrammetry model. One is a neural radiance field, and then the second one is this Gaussian splat, which has the ability to do more of a real-time rendering into an augmented reality format, which would give you the ability to kind of skip some of that more involved processing and be able to have a higher resolution potential image. But it would also integrate in that real time into like a headset, which would allow you to use the virtual imagery immediately. The neural radiance field also has this interesting capacity to be able to integrate into a large language model. So as we've gone through this like photogrammetry, this is kind of the example of processing of these three-dimensional images through a neural radiance field, which allows you to have really complex view of your three-dimensional anatomy. That's obviously a cadaver, but what this integration into a large language model would potentially provide is being able to interrogate this model so that if once you have this set, you may be able to like ask it questions if it was linked to a large language model that was informed by data that corresponded to this. We could also change the projection of that image so that you can see different components of it. And this is the final kind of version that we have been working on, which is the Gaussian splat, which is, again, utilizing this type of technology where it would almost immediately be able to be translated through a smart lens or smart glasses to be able to see those things. So assessment of accuracy currently just with the photogrammetry is something that could utilize for training if you're trying to create some type of construct and you have a standard that you're trying to set, then that is something that you could utilize as the attending to have be matched or a goal interoperatively for your trainee and utilizing that kind of volume assessment as well so that you're be able to really measure what the changes that you're looking for. There is obviously some error with the mapping and alignment of the point clouds, but certainly there's opportunity to achieve better symmetry if we have this feedback other than just kind of trying to eyeball what is actually happening. Ultimately, utilizing smart lens to do a lot of these things will be really impactful and really being able to align this with intraoperative navigation is something that obviously is not just beneficial to our trainees, but also just for clinical care and being able to kind of look at complex changes. This is an example of just using the intraoperative navigation for like box osteotomies and how we can try to utilize those wearable devices for being able to assess the accuracy with our predetermined plan. So I think the images that we're creating this is one example of a computer vision model, but that you can be something that could also be utilized as an opportunity to query once we're able to do that on more complex platforms. This is another system that has been utilized widely in the spine space, which isn't as much something it's going to assess a learner, but is just immersive augmented reality that is through this HoloLens. Again, it's just another smart lens that can that can be controlled by the surgeon intraoperatively. And this is another cranial vault case, and this is just the alignment of the CT scan with the live image so that you can kind of see where you you are interoperatively. This is kind of an example of the markings so that you can utilize the markings from your preoperative plan. And these are some other kind of images of utilizing this tool intraoperatively, both for visualizing the CT scan through your lens as well as your 3D dimensional plan if you're utilizing virtual surgical planning and being able to align those cuts or osteotomies with what you're seeing through that smart lens. And I think that this is something that will, continue to improve over time. These are just showing some of the alignment with those images. And this is kind of a live video or just able to kind of scroll through some of the slices of the CT scan through your hand motions and able to visualize like any of these components that you're trying to see in that time period, which I think has tremendous applications for education as well as for clinical care. Is another view of it from a lateral viewpoint. Recording. And you can see just utilizing the hand gestures is able to do that. So I think looking forward, certainly there are a lot of opportunities for just our intraoperative imaging to improve our educational approach, potential to create some more objective tools. And I think, that there are many, many applications of this and that we're really at a crossroads, just both from an education standpoint on every possible level with the just explosion of this technology. But I think, particularly aligning with the changes in plastic surgery education and the goals to really transition to competency-based learning, that the use of technology is really going to be required to overcome a lot of the challenges and the assessment that are required to have, widespread competency-based education. And so how can we utilize this ability to record and analyze continuously, both in our clinic encounters, through case discussions, and intraoperatively with technical skills so that we can take a lot of that intermittent subjectivity out of it, the burden on the evaluator, and try to continue to try to eliminate some of the biases that we find. So I just want to thank Kiefer Forseff, who's a neurosurgery resident and has been collaborating in this project with the photogrammetry, and Julia Schmidt, a medical student who's also been a critical collaborator of this team. So thank you so much, and I look forward to a rich discussion.
Awesome. Thank you, Dr. Gosman. This is really great. There's so much that you covered. I've had a little bit of experience with augmented reality in the operating room. And one of the biggest limitations that I find is the intricacy of operationalizing it from case to case. And specifically, the predictive plan, the augmented reality is only as good as the predictive plan that you have. Have you found that artificial intelligence or LLMs or something along those lines can help with that process as well to kind of improve some of those pain points to make this more accessible to everyone?
Yeah, I mean, I think it's a great question. I mean, I think there's like this is like a very fascinating space, but like getting it to a point where it's like finely tuned enough to be like broadly applicable is for sure the huge frontier and challenge that exists. I think it's really compelling, like striving toward creating that type of like opportunity where we can transition and integrate this into large language models that I haven't like been able to actually, do in practice yet. It still requires like a lot of processing after the fact. But I think that's something that would be really, really fascinating and really like assist in our ability to deliver such accurate care. I think, the navigation space and how we've been able to kind of utilize that for a long time is like a natural kind of component of how we can do this, but then, integrating it into spaces where, like, if you want to inquire about things, that you have that information. But I think that also depends on like the work like Graham is doing, so that you have like actually large language models that are going to be informed in such a like specific manner to be able to, really help you answer those questions.
Awesome. Okay, we'll turn it over to our final speaker, Dr. Rubin, who's going to be talking about surgical leadership. And I think you're muted. There you go.
Great. Can you guys see my slides?
Yeah.
Great. Well, thank you for the opportunity um, to speak on this panel. This has been really informative and just a really exciting area. I'm going to take a little bit of a different approach, a little bit of a different tact, and we looked at AI and clinical decision making and intraoperative assessment and training and prediction. And I'm going to talk a little bit about how we might be able to utilize AI in surgical leadership. And my disclosures, I do have some IP around AI technology assigned to Pitt. It's not currently licensed. And I'll also disclose that AI did not make this talk for me, but I will show a lot of AI generated content, mostly to demonstrate concepts. And I really liked Amanda's slide where it's like you try to design an image with AI, you actually spend more time doing it right now than if you just go and search Google Images and play with Photoshop a little bit. But we're all dipping our toes in the AI waters. And I am by no means a tech geek, but nor am I a Luddite or a technology naysayer. I'm kind of, middle road, someone who uses technology a lot and relies on it. I've never spent a lot of time. I've learned a little bit of programming, but not a lot of it. But I've really been excited about getting involved with AI and working over the last couple of years on some really neat projects with AI and operating room efficiency. So I'm definitely an advocate of the technology. Um, but I'm approaching this from the perspective of, okay, I'm a surgical leader. I've been a department chair for a long time. What are all the things that I do as a surgical leader? And then how can AI help me with this? And these are all the things that those of us who are surgical leaders do in our regular jobs: strategic visioning, execution, complex decision making, building teams, crisis management, budget management, compliance oversight. I mean, it's a pretty big list. And anything that we can use to make our jobs more efficient and more effective is going to be very useful. So then I look at, well, what does AI do? And AI, it's a prediction machine. It's actually, machine learning's been around since 1959, but over the last decade or so, we've hit deep learning and generative AI and then large language models, so that the data gets processed much more rapidly and in much greater volumes. So it's really great at synthesizing large volumes of information, identifying trends not immediately visible to humans, and generating structured outputs that can accelerate cognitive work. And that's really valuable, limitations notwithstanding. And right now, we're all kind of going down, the rabbit hole we go down whenever we get new tools. So this thing, before electronic organizers, like, man, when I was a med student, I had one of these things and I went down the rabbit hole and, you just have pages for everything. I could manage an entire service, all out of this Filofax. And, so we're going to go down the AI rabbit hole, and that's okay because we need to explore all the ways that this can help us and what the best applications are. But let me talk about the risks and pitfalls up front. So we have to avoid, and it's very easy to do, the tendency to treat AI like an oracle. It's just a tool. It's not the definitive wisdom of the universe, although it will make us think that it is because it's designed to do that. Biases, we talked about that in the last two talks. these are really dependent on the data that they're trained upon. Human judgment is key for interpreting the results. It can hallucinate, as we've heard from the last two speakers. It can literally make things up, and that's a problem. So you need the validation, which is one of the things that Graham talked about: the validation and accountability, privacy. Can't put proprietary data into an AI model that's public, or everyone's going to see it, especially PHI, or you've got a HIPAA violation. Many AI models are sycophants. We'll come back to that in a little while. They will compliment you, they will praise you, so you engage more. It's like the social media hit on steroids. The dopamine is surging because you've got your own echo chamber. Moreover, it's easy to replace team engagement with AI interactions. I can have a very pleasant conversation with AI, voice conversation on my drive home, and it won't get tired of me or annoyed with me. AI output is not based on judgment. I mentioned that, and different models are better at different tasks. So here's a table that I put together, and I did put this together using ChatGPT. Say, hey, tell me the different training data the models are based on, and their internet search capability, which is really important because this is the dynamic retrieval aspect of this, and the core strengths. And it told me that ChatGPT has the best overall balance. And so then it kind of summarized this for me. Okay, here are the big models that are out there, the big six models. And it kind of gave me some perspective, on this. You want generalized things, then go to ChatGPT and Claude. You want workflow, you want to stick with your enterprise Copilot. But, I actually asked ChatGPT, like, are you kidding me? Like, you put this table together, are you biased? And it actually told me it could be biased, but it's not necessarily wrong. I mean, that's a pretty clever answer. And then it said, look, the important thing is no single model is best. Fitness depends on the task. But it praised me for asking the right question on this. So, these are cautionary notes because this is a machine. So how you interact with the model is very important in generating the information you're seeking. First, you have to know how the model was trained, and what its capabilities are, but you have to get really good at the interactions. And the interaction is there's a whole new evolving term called prompt craft, and you actually can ask AI, to perform a certain role. You are an expert data manager. You are a patient who has an eighth grade education, and I'm trying to generate content for you. You want to tell the task, you want to know any specific requirements, specifications, and you want to give it instructions. And so you have to get used to being really specific, providing context in your prompts, using constraints. And you can say, hey, I need one paragraph, or I need three paragraphs, or I need two sentences. And the iteration is really key because the more you help it get context, the more you can refine your answer. And as I mentioned, with this idea of prompt craft, there's role playing. Act as, as I said, like a patient I'm trying to communicate with. Act like a Python developer in this case, and then give it a lot of context and use the iteration. So there are a lot of algorithms out there, a lot of for prompt craft. This is one called the craft method: context, role, actions, format, target audience. Who do you want this to go to? But again, there's no one that's going to do it all for you. You just have to keep this in mind. This is kind of an interesting book that I read called The AI Driven Leader. It's not technical, and it's an okay book. But this guy Jeff Woods uses a model called the CRIT framework: context, role, interview, which is kind of neat. And I'll show an example of this. Interview me to get context, and then here's the task I want you to do. So this is a really important slide because you have to, if you generate a prompt and refine it, you can actually test your prompt in different models. And I'm going to show an example of that. And then I'm really learning that the iterative stage is key to getting the information that you want, because you're not going to get it right away. And there's a real process of refinement. It's like doing a Medline search, or some kind of search for literature. It'll take you a while to hone in, but when you hit it, you get a lot of content. And interestingly, this is a really cool thing. You can generate content with one model, and you can use another model to critique it and revise the work, which is really interesting. So now let's go back to, okay, how can a surgical leader use AI to do things better? Well, I can make my team more efficient by automating tasks. Yes, that's a no-brainer. Data extraction and analysis relevant to surgical leaders that you may not get from your organization. I'll show an example of that. Make meetings more efficient by recording them, getting a transcript. I will say one thing I've learned about that is that if I'm recording a meeting with AI and I want it to summarize action items, I will speak that at the end. I will summarize. I will say that list because AI may not get it right. So there's all these things are areas where this can help us even with strategic planning. You can use AI to take your strategic plan and something the military calls red teaming, which is basically a devil's advocate approach, and say, rip this apart and tell me all the weaknesses of it. So let's do a test drive. And I'll show you some examples and we'll see if it falls somewhere, where in the spectrum does it fall? Is it the old guy on the antique bicycle? Is it an F1 or is it like the, futuristic Tron motorcycle? So this is a real example. So I need, as a department chair, an operative log to understand the case profile for all of our surgeons and distributions of cases across the department. And I've got billing data, tons of it, and CPT codes, but that doesn't tell the story well enough because, as we know, you can't tell aesthetic breast versus breast recon. So I want to have a case list, just like you would submit to the boards. I have access to all the op notes. They come to me in an email feed. I just siphon them off the same email feed that our coder gets. So what have I been doing? I've been having someone manually extract the data. This is before AI. What if we used AI instead? So here is the template I want it to fill out. I want to know the surgeon, hospital, surgery date, patient name, medical record. And what I really want is title of operation and diagnosis, and then I can categorize it. So here's my prompt. And I tell it, I've got a batch of operative notes. I've got 20 operative notes in my email. And I'm going to give it to you just as I'm getting them in the email. And I want you to extract the data and fill in the operative note sections using one row per patient. Give me an Excel file back. So what does it do? So I use my Enterprise Copilot for this. It wrote me a Python script in like a minute. And we refined it a little bit through iteration, but within 5 minutes, we had a working Python script. And I'll tell you, for context, I had a super bright med student with a programming background who was working on that Python script for like months and was still troubleshooting it. So I got this, and I redacted all the patient information, and these are like the real surgeons, and I got pretty much everything. Title of operation, preoperative diagnosis. This is great. So now, so now I want to categorize these. So I went through and I made categories and I fed it the categories and said, okay, assign from a list of categories, assign a category to each one of these cases. And it did pretty well. It got one wrong, and it was a little tricky. But I called it craniofacial and it said breast reconstruction. But, you can double check these. But this is huge because, every month now, we can do this once we get the system up and running. And I'm not going to do this myself, but instead of having an assistant spend 10 hours on this, you can have an assistant spend 45 minutes if they're skilled. And further exciting potential, knowing that I can extract that kind of base data from operative notes, then we can use operative notes and immediate post-operative notes as data entry fields for clinical outcomes and do natural language searching for this. And we can really streamline the chart review process because if we get used to putting data in a certain way that it can be retrieved, then that's really great. So the more we have good interaction with our EMRs, the better we're going to get at this if we also help feed the information in. Here's another here's another thing. This is again real that I did. So I have like spreadsheets, massive spreadsheets of billing data for our department. and it has payers, it has reimbursement, it has charges. So I did a little test. I said, okay, take this for a couple of years and pull out all of the breast reductions that we did in our department. But I want to separate out cases that had zero reimbursement that were denied. I want the average, I want the range, I want to show by payer, I want payer mix, and then now I can't show you the actual numbers because those get that'll be a problem because it's proprietary. But here 1,460 cases of breast reductions that we did like over 2.5 years, and it even tells me the assumptions that it made. And by the way, this is the Copilot analyst agent, so it tells you all the assumptions that it used, and then here's all the payer mix. Again, I kind of blinded what these actually are. But this is actually really, really valuable data. Especially, it tells me I can pull out the denials as well, and our revenue cycle doesn't necessarily catch those. So that's really helpful. Now, what about strategic planning? I tell it I'm opening a breast reconstruction clinic for our breast surgeons. Our department has really been working on this, and help me identify key strategic or operational blind spots, data I need to gather about markets, potential risks or barriers to implementation, and critical decisions. And then again, this was our enterprise Copilot model, and it starts asking me questions for context. Are you, why are you doing this? Is this a health system endeavor? Is this a department level? Should I assume, what's your catchment area and where we have to look out for competition? And then you want me to frame this as a hospital-based clinic or a physician-led clinic with hospital OR access? How do you want the finances to run? So then I ran into a problem. And the problem is that because I used our enterprise research agent, it actually searched all my emails for discussions about things we've really been working on. And it gave me a very context specific thing that I can't really show. I can show, this is all I can really show because it told us about, blind spots we should be looking for, what resources we use, more of a checklist. But then it gave me 4 times this amount of information that talked about OR capacity at certain hospitals that we go to, and it talked about competition, and it talked about market share. So it can actually get pretty precise, and it can be very helpful. Again, you have to use your judgment in looking at it, but it's a good sounding board. So we can use this as a sounding board for innovation and problem solving, looking at feasibility assessment, stress testing ideas, clarifying value propositions, and developing communication pieces for different audiences. Of course, first draft, and there's a question, where do we overuse this? And yeah, sometimes in written communication. So now I'm going to show you one more example, and we're going to do a multi-model test and then some synthesis, some analysis. And I'm definitely in the spectrum kind of more feeling the F1 vibe, that we've got a really well-tuned machine, not quite the, Tron futuristic thing yet, but something that's going to be really useful. So we're going to go back to breast reconstruction. And we want to really tune our patient experience. So I designed a prompt, and I said, please create a concise bulleted list of the top 10 elements of the patient care journey that patients found to be representative of excellent patient experience and/or high quality care. Then make a parallel concise bullet list of top 5 elements that led to that patients complained about they found to be representative of poor patient experience and/or poor quality care. And then before starting, interview me, asking 1 question at a time, up to 3 questions to gain more context. And I ran this through ChatGPT, Copilot, OpenEvidence, Grok, Gemini, and Claude. And this is what I found. What I found is that the lists were actually all different from the different models. This is the Gemini list. And you can see the things that it came up with. I won't read every one of them. So then I asked the question, okay, if the lists are all a bit different, let's look for commonalities, and maybe that will be helpful. So, so I'll show you a table. Before that, I'll say the interview questions were also very different. So Gemini asked me, should I put higher weight on the pre-op navigation or post-operative recovery phase? Copilot says, what single stretch of the journey do you want these insights to optimize? And kind of similar to that first question, but it broke it down more. And then ChatGPT said, should I focus on academic centers, NCI designated programs, or community hospitals? So very interesting. So then I use ChatGPT to sort and analyze the lists and make a table. And so what I did was I had AI make a table and I said, look at all these lists, show me commonalities, show me things that crossed all 6 models, and then in descending order. And it came out number one, seamless multidisciplinary coordination, one team working together. Very, very interesting. And then you could see the decreasing probability in the different models. But this is it gave me a pretty good list of this. I could go back and look at it in more detail and then decide which list do I like better, do I think is more realistic. Then I had it, instead of 15 unique answers from the 6 different models, I said, summarize this into discrete domains to operationalize. And it actually did a very good job there. And, care coordination, multidisciplinary, high signal response. And same with patient education and expectation setting and communication. So it gave us things to focus on, which is really good. Now, what about poor patient experience? Same thing. We got 10 unique answers from the 6 different models, each asked to make a list of 5. And I ran the same experiment. And I said, put these together by frequency across the different models. And what is the number one thing? Fragmented care, poor team coordination, conflicting information, which correlates to, what's the one thing we have to get right, which is really interesting. And then I had them put the themes into discrete domains to operationalize. Same with the successes, with the successful strategies, and these are things to avoid. So this actually, all taken together, makes a pretty good roadmap of things that we need to, do. Now, I think that, if you sat down with your entire care team, could you come up with this? Of course you could. But this is a good representation of how we can use this to generate good checklists, to generate thorough maps and lists, and then we can decide what we want to focus on and what we're doing. So, conclusions. Yeah, AI, it's the real deal. It has good applications, but it's a tool, and we have to learn how to use it. It is to knowledge work what automation and machinery is to manufacturing. So our job as surgical leaders is to figure out how to best adapt this technology to our professional arenas. I call this, new technology, but in the framework of our same strong values as surgeons, as ethical surgeons. So AI is going to impact most jobs in healthcare and science, decreasing the need for some jobs, but I think it's also going to create new jobs, and we have to help steer this. So great quote from Jensen Huang: AI won't take your job, but someone who uses AI will take your job. So I want to end with a shout out to Solomon Seckler and Maria Escobar, our 2 research fellows in our Scalpel Cost Effectiveness Lab, who are co-authoring a chapter for Jesse's Clinic in Plastic Surgery volume on AI on this same topic. It's interesting. For those of you who've watched, 2001 or read the book, this came out in 1968. And what a great example of the biggest fear that we have of AI just like kicking our butts and killing us and taking over the world. But it was a really, really great example. Thank you so much for your attention. I'm happy to answer any questions.
Wow, thank you, Dr. Rubin. That was a tour de force, really amazing. And I look forward to reading your chapter and maybe we'll offering it to all of the audience members to get all the detailed prompts and data that you presented because it was so full. It seems, it's pretty novel to do. It's almost like you're doing a GPT-based meta-analysis, right? You're using all of the different engines and their relative strengths to combine and create one Voltron-like super recommendation or super output based on all of this. It's really really cool. Are you able to do that? Um, are you using ChatGPT to do all that that synthesis together? And do you feel like that creates even more bias as well?
No, that's a great question. So I use chat, applet. I actually personally switched between the different models and
Hmm.
fed the prompt into the different models and pulled the output out. So I didn't use one model because to say, hey, do all this work for me in the different models. Because number one, I wasn't sure if it would do it, and number two, yes, I'm worried about the bias of that model. So I wanted unique information
Yeah.
from each model.
Um, I have a question for all of the panelists. This is a really exciting technology. I think, Peter, your analogy to the assembly line and automation is really appropriate. Rarely do we see such large sea chains, maybe the personal computer, the smartphone, as what's happening in the AI revolution right now. With all technologies, there's an opportunity to over adopt. And so, my question to each of you is: are there situations in your specific areas that you mentioned and that you spoke about where you feel that AI is not up to the task, or where you have seen people or yourselves have made mistakes because you've relied on AI, or you've caught mistakes that AI would have created? What are some examples when AI is inappropriate for use in your relative fields?
I'll start, and this is kind of echoing Graham's theme that when you're using it for clinical decision making, you have to be really, really careful with that because it's like having a really bright, M1 med student and sending them down to the library and saying, go tell me what I should do about this, read some papers, and you may get some wrong answers. So I think that it it can help you find the information, but it's not necessarily going to give you real credible information necessarily. So the judgment part of it is really, really key. And your interpretation is really, you can't rely too much on the interpretation when you're looking at it for clinical decision making. And even for operational tasks, when I put different spreadsheets in and said parse this data, look at it this way, some of it comes out and I'm like, yeah, this doesn't sound right. Like if we're earning this much on breast reductions, then the whole department should be doing nothing but breast reductions all day and all night. But no, it made some errors in the calculation. So you have to go back and figure it out. So that validation is key.
I agree. And just, sort of an up to the week, sort of analogy or example, I should say, is like actually ChatGPT or OpenAI came out with this ChatGPT Images 2.0. And, when you look at these image generating models, like they continue to just like amaze you, right? And so right now, like you can actually ask this model to generate essentially a netter like image of any anatomy or even if you wanted to like try to demonstrate a surgery. So I actually I saw a post of someone sort of extolling the virtues of this. It was actually a doctor who was extolling the virtues of this thing, and basically they had asked ChatGPT to generate a netter image of the head and neck, and they said how amazing it is. But actually, if you looked really carefully at like the little label, it was near perfect. But if you actually looked at the little labels of all of like the muscles of facial expression, like still half of them were wrong. So we're definitely not, we're kind of in prime time, but you certainly can't fully trust any of this stuff. There always has to be a human in the loop. And certainly as we get to real real autonomy that we give these systems, whether it's for clinical decision making, or in the OR with autonomous surgical robotics. We have to be many levels better than where we're currently at.
Yeah, I mean, I agree. I think, embedding some type of validity testing, because obviously things continue to improve. But I remember a few years ago, one of our like residents put together like just a talk on like, can AI write like do basically a grand rounds on AI and like generating these like reference lists that look very real and like refining your prompt so that it's like based on peer reviewed literature, but then like when you go and like look these things up they were like completely like false. So I think it's whether it's the images or you're using it in a clinical environment, like how can we bake in that validity testing and the accuracy testing along the way, because I feel like it's such a moving target. Now you can kind of refine some of those prompts to eliminate some of those hallucinations, but then are other ones just like being generated? I think it's a like an ongoing challenge.
Yeah, that's awesome. I will tell you just personally, speaking about the sycophantic nature of AI, I really have to check my own myself because I think whenever I'm chatting with ChatGPT or anything else, that I am onto something brilliant just in how it's reacting, and I'm not. We all have to learn how we interact with, especially these LLMs specifically. Great. Well, I'll turn it over to Dr. Sachs to close out the session.
Dr. Goldstein, Dr. Schwartz, Dr. Gosman, Dr. Rubin, and everybody listening. Incredible, inspiring talks. It's really fun to see this in action. Technology Committee AAPS is committed to really bringing innovative topics to the group, and I think all three of you and Jesse is the moderator hit it out of the park tonight. Um, I remember as a kid coding in BASIC and building small computers and putting RAM in it and playing Zork, word games for those that are listening that are old enough to understand what that means. Um, there's something called the rule of nines where you keep going out, 9, 9, 9, 9, add out to the right of the decimal point. And today I looked through my meta glasses at a broken mandible, and the thing told me I was going to do ORIF of the mandible. Didn't tell me what I was going to do, but it knew what it was looking at. In clinic, I use digital scribes. We piloted it here at WashU for a couple of years. If you took away the digital scribes from me right now, I think I would have to retire because it helps create my note. And the next step is to help guide me in what I should do. So, I think what this committee, the technology committee, is going to do here, because the leaders here on this are in leadership positions in all the other societies. We're going to keep bringing this stuff to membership. But I will say in closing, I think we are at the cusp of a revolution in real time. And this talk a year from now is going to be a lot more granular and a lot more specific. And I do think there's going to be less confabulation and there's going to be more specific ways that we remain as really the human in the loop. And that point about human in the loop, I think is critical. We as surgeons are not going to be replaced anytime soon, but we are going to be augmented with technology, both in the operating room, around the operating room, in the clinic. And, what also Dr. Gosman really keyed upon was in education. And so, it's an incredible talk tonight from everybody. Thanks for contributing, and hopefully we'll see everybody in Hawaii, and we'll make an announcement soon about our next technology committee sponsored, webinar. So great job, everybody, and have a good night. Really, really awesome.
Thanks, everyone.
Good night,
Thank you.
everyone.